Hi students, in this video we will discuss a very important concept called structure padding. Okay, now let us see what is structure padding. So in order to understand this concept, please watch this video till the end. Now here example, here I have a structure called person. Inside this structure I have two character variables called char a, char b and int x. Now here if you observe how many bytes of memory this character variable will occupy, 1 byte. How many bytes this b will occupy, 1 byte of memory. 1 plus 1, totally it is 2 bytes. So b will also occupy 1 byte of memory. How many bytes of memory this x will occupy? This x will occupy, as it is an integer, it occupies 4 bytes of memory. Now how many bytes a structure variable will occupy? As we have discussed earlier, the statement was sum of memories of all its elements. So how many bytes it should occupy? Totally 6 bytes it should occupy. How many? 6. But if you run your program and see the output will be different. How many bytes it is occupying? 8 bytes of memory it is occupying. So I will run the same program at the end and I will show you that it will occupy 6 bytes. Now let me explain you why it is occupying 8 bytes of memory. That concept we call it as structure padding. That concept we call it as structure padding. So here, what is structure padding? First let me explain you. Here structure padding means adding some extra bytes in the memory. Structure padding is a concept in C that adds one or more empty bytes between the memory address to align data in the memory. That is, it will add some empty bytes into the memory. Now let us see why it will add empty bytes. What is the reason for that? Now here let us example, we have a char a, char b and int c. It will occupy 1 byte, 1 byte and 1 byte. Totally it should occupy actually 6 bytes of memory. Now so here what happens is the processor does not read 1 byte at a time. It reads 1 word at a time. So in C, the processor will read 1 word at a time. What is the meaning of 1 word? Here if the processor is a 32-bit processor, it will read 4 bytes at a time. And if the processor is 64-bit processor, it will read 8 bytes at a time. So here the processor is a 32-bit processor. So at a time it will read 4 bytes at a time. In the structure memory, at a time it will read 4 bytes. Now what happens here is, now here we have a 32-bit processor. The pictorial representation you can see here, how the memory is allocated. For character A, 1 byte is allocated here and each box represents here 1 byte. And for B, 1 byte is memory allocated, and for C it will allocate how many bytes? 4 bytes of memory will be allocated. If the memory is allocated in this way, whenever the processor is reading, so in the first cycle it will read first 4 bytes at a time, and in the next cycle it will read the next 4 bytes, and these 2 bytes are empty bytes. Now what is the problem in this case is, it is reading A and B, no issue. There is 1 byte of character A and 1 byte of B it is reading. But when it is reading integer value, it is reading in 2 different cycles. In the first cycle it is reading half of the integer, and in the second cycle it is reading half of the integer. That is the problem with, that is number of cycles for reading this value will be increased. It is for reading one variable, one data. It is taking the help of 2 cycles. To avoid this problem, internally what happens is this padding will occur. So what happens here is, how the padding will occur is, A and B 2 bytes, then here 2 empty bytes will be added. In the first cycle it will read these first 4 bytes, and in the second cycle it will read the next 4 bytes. This complete integer has read in a single cycle. This is the advantage. But the drawback here is extra bytes of memory will be added. So that is why these 2 bytes are added. Here 1 byte for A, 1 byte for B, 2 empty bytes are added, and 4 bytes for character. Totally how many bytes it is occupying? 8 bytes. Now in a 32-bit processor, the how many bytes the structure variable occupies is divisible of 4. It will be a divisible of 4 in structure padding. Okay, now so now let us see the example that is about structure padding. Now let me execute and show you the program once again. Now here I will use char. So we have seen one example earlier, if you remember, int age, then char name of 20, float height. If you remember, in structure we have seen how many bytes this structure will occupy? 4 bytes for integer, 20 bytes for name, and 4 bytes. So 7 4s are 28. So no extra bytes are added in this. Okay, now let me run this program, compile and run. You can see 28 bytes, no problem. But what I do here is I will add char name of 30. Now compile and run your program. How many it should occupy? How many bytes it should occupy? It should occupy 30 and it should be 38. Now compile and run your program. How many bytes it is occupying? 40 bytes. So 2 empty bytes are added into this. Okay, now this is why, because in order to read in cycles, so 2 extra bytes will be added. So that is about structure padding. Here we can avoid structure padding. That is, I want to occupy only 38 bytes. I don't want to add extra bytes. To avoid structure padding, here we have preprocessor directive called pragma pack of 1. Now if you run this program, this will avoid, that is, it will read 1 byte. 1 byte separate package will be done in this case. So to avoid packing, you can see now it occupies 38 bytes of memory. That is about structure padding. Thank you for watching. If you have any doubts, please comment.